students. Hello everyone. Hello everyone. So in my few last videos I have shared trigonometry with you, right? That trigonometry was up till 10th standard level. Now I have seen many of you have commented that you want to do surds, you want to do integration. Somebody said you want to do differential equations. Somebody said I want to do whole maths. So it's very good. I'm really impressed with your whatever you are commenting and you for your appreciation. I'm really thankful to all of you. So today, as we I cannot start integration directly, right? When I am showing you trigonometry, I have to go for the trigonometric values which are greater than acute angles, okay, where we will consider obtuse angles also. So today I have just given a break to trigonometry. Let me see few more comments regarding trigonometry, and then we will complete trigonometry and will gradually move to our differential and integral calculus as you have asked. Okay, but today I am going to start with mensuration problems. So mensuration is related to the figures, 3D figures. Okay, 2D figures, all of you know 2D figures. What are 2D figures? 2D figures are rectangle, square, circles, triangles. Those are 2D figures. Okay, and but today the mensuration problems that I will take, that I will do, and I will show you the formulas based on that. That will be depending on the 3D mensuration problems. Okay, in case of 3D problems, 3D solid figures are what type of figures which you cannot directly show it on the board, right? You have to something you have to imagine also. So figure like say suppose you have a joker's cap. Okay, so that is a 3D figure where you can see the front portion, the side portion, but the back portion is not visible to you. Similarly, if we talk about say suppose your pencil box, right? In pencil box also we can see few of the things, few faces, but we cannot see the back portion. So those are 3D solid figures. Okay, so today our topic is mensuration. Under this topic we are going to learn about volume, and surface areas of solids, right? Okay, let us first discuss about cuboid. Our number one part is cuboid. Cuboid, if we see, the figure is like this. This is a cuboid. Okay, you can think about matchbox, chalk box, book. These are the things which we have in our daily life. Okay, in daily life we are using cuboid. So you may have also observed that in case of cuboid the length, breadth, height are different, or maybe any two terms can be two, two, either length or breadth can be the same. So let this is our length, this portion is our breadth, or you can say width, and this is our height. Okay, so in case of cuboid, first thing is, if we are talking about its volume, let us talk about volume. Volume of the cuboid will be length into breadth into height. Okay, next is total surface area, right? So this is equals to twice of length into breadth plus breadth into height plus height into length. Now see, all of them as are related to mensuration, so this will have a unit, right? Volume is always measured in cubic units, so I am just going to write cube units. Cubic units means, say suppose you are measuring it in centimeters, so it will be centimeter cube. If you are measuring it in meters, so it will be meter cube, right? Similarly, surface area, as it is related to area, so it will be square units. Okay, next is lateral surface area. Lateral surface area is what? Lateral surface area means this area surrounding, this surrounding area. Okay, this is lateral, that is sum of this plus this plus this, the back side, sideways, all addition of that. So this will become equal to twice of length plus breadth into height. It is also in square units. Now, as I said, lateral surface area means sum of all the sides. All the sides means literally, right? Not the top one, not the base one. So here I have taken 2 length plus twice of length plus breadth into height, right? Now, if I say that I can also write it as area of 4 walls. Okay, also resembles with area of 4 walls. So in case of area of 4 walls, the formula is the same. Twice of length plus breadth into height. Okay, next is your diagonal. Now how we will measure diagonal? Diagonal is this portion from this corner to this innermost corner. Okay, this corner to the innermost corner, this is our diagonal. So diagonal will be given to us by under root of L square plus breadth square plus height square. This is in limits. Okay, so this is all about our cuboid. Now we'll learn more about cube. What is cube? Cube you may have seen in dice, right? Or as sugar cubes, or as ice cubes. So these are, you know, cubes. So in case of cube, what happens? All the three parameters, that is length, breadth, height, all are equal always. Okay. So next is our cube. Okay. Cube where length, breadth, height all will be equal. This is a square, you can say. The combination of two squares, you can also say. Its faces, its edge, its vertices all are same as cuboid. Okay, the difference between cuboid and cube is here length, breadth, height in case of cuboid are different, and in case of cube length, breadth, height are all same, equal in length, right? So we can also write the side as edge, we can also mention it as edge, right? So this particular part, if I am writing as A, or I can say it is our edge. Okay, so this is my edge. Now when I am writing about its volume, it is also the same, length into breadth into height. But what will happen? In this case, our length is also A, breadth is also A, height is also A. All three are same. So A into A into A will be equal to A cube, right? Or else I can write it as H cube. Somebody may call it as somebody may also call it as side cube. Anyways, it can be said. Okay, so this is cubic units, right? Then comes total surface area. So total surface area is as like this one, right? It is twice of, see, length, breadth. I am using the same formula as I have used in cuboid. So length into breadth, this is the dot I have given. Okay, dot means product, right? Plus, and then breadth into height, that is also A, plus height into length, right? So what will happen? Twice of A square plus A square plus A square. So which is further equal to twice of 3A square, which is equals to 6A square. Square units. Okay. Square units. So my total surface area in this case, this is the total surface area, right? And the formula is 6A square. Okay, this is our total surface area. Okay, then next, number C, that is lateral surface area. Lateral surface area is twice of length means A, breadth means A, height means A. Okay, so this is twice. A plus A is 2A into A. Okay, so this is equals to 4a. A into A will be A square. So this is 4a square units. Okay, this is our lateral surface area. Now when I am talking about diagonals, so diagonals is equal to root 3 a units. Okay, this is my diagonal, right? So this is how we can go for cuboid and cube, right? Right now I am going to explain you the formulas, that how it comes, how the formula becomes, and then after we will do the questions based on this individually on all the type of question, all the type of solid figures, and then we'll move for the combination of solids. Okay, combination means you will have cylinder attached with cone, the other side is attached with a hemisphere, or maybe a sphere is a spherical ball is dropped into a cylindrical vessel. So what will happen? So those type of questions we will do, and keep it in mind that mensuration is very interesting, very very interesting. Okay, only you have to understand about the basic things like edges, length, breadth, height, and accordingly you have to memorize the formula. But memorizing the formula means you have to do a lot of questions based on this, so formula will be memorized very easily. Okay, now we are going to move for cylinders. Okay, so we learn about cylinders. Okay, so in case of cylinders we will learn about hollow cylinder and solid cylinder. Let us understand about solid cylinder first. Okay, so I am going to show you about solid cylinder now. Solid cylinder, the shape is like this. It's circular, then long, then again circular. Okay, this is like you can see, you may have seen in measuring jars, right? Or pillars also you may have seen circular pillars. um, then tunnels you may have seen circular tunnels. Then rollers which are used to for making the roads, you know gas cylinders. So you have already seen such type of figures, right? So suppose this is my r is the radius, r which is the radius, is the radius of the cylinder, and this part is h is the height. Okay, h is the height. Now come for the first again, that is volume. Volume is equals to pi. Pi is a fixed value, that is 22 by 7 or 3.14, right? Now pi is a rational number or irrational number. We will discuss about it later when we will do rational and irrational numbers. Okay, right now come for this one. Pi value is 22 by 7 or 3.14. Now this is pi r square h, cubic units, right? B is our curved surface area. As in case of cuboid and cube, we said lateral, right? But as this is circular, so we will say curved surface area. Curved surface area will be equal to 2 pi r h square units. Okay, that is this surrounding part, that is this part, surrounding part all over. Okay, 2 pi r h. Next is total surface area. Total surface area is this surrounding, that is the curved surface area, plus this topmost part and this lower part. Okay, so this is this surrounding portion, that is curved surface area, this topmost part and this bottom part, right? This will give us our total surface area. So here we will write curved surface area plus area of two bases. Now curved surface area we have already learned here, 2 pi rh. So we are going to write 2 pi rh plus area of two bases. These bases are in the shape of circle, and we all have learned that circle is a 2D figure and the area of circle is pi r square. So this is pi r square. Okay, so either we can keep our formula as it is, or we can take it something common. So what we can take common out of these two terms? We can take pi r and we will left with 2h plus r. This is square units. Okay, so this is all about our cylinders, solid cylinder. Now I will tell you what will happen if we have a hollow cylinder. Now where you have seen hollow cylinder you may have seen in iron pipes, tunnel also. I said this is cylinder, but tunnel is not a solid cylinder. Okay, tunnel is a hollow cylinder, right, which is made up of thick metal or thick stones and all those things. So that is a hollow cylinder. Similarly, you may have seen suppose rubber tubes, or you have maybe you have seen empty bottles, right? So in such case of hollow cylinders, suppose this is the figure, circular top, circular body, circular base, but as it is hollow, So this portion is like this. Okay, now here this innermost part is radius, but this is the inner radius. Okay, so I will write r, that is inner radius. This outermost part this is capital R. It is again a radius, but it is capital R, that is the outer radius. Okay, but the height for the cylinder, whether empty, non-empty, solid, so it will always remain the same as H. Okay, there is no change. Now what will happen? The very first point comes, what will happen with this small r and capital R, right? So here in this case, firstly we have to find out thickness of the metal by which this cylinder was formed. So thickness of metal will be equal to capital R minus R units, right? Next comes volume. Volume of what? Volume of this metal. Okay, so volume of metal or material, better, because I don't know whether it is made of metal, whether it is made of stones, whether it is made of plastic. So better we can write it as material. Volume of material will be external volume minus internal volume. Okay, and what is my external volume? External volume formula is going to remain the same. It is not going to it's not going to change. So pi r square h is the volume. So in case of external volume, I will write it as pi capital R square h. H is not going to change. H is going to remain the same. Only the radius will change. Minus pi r square h. Right? Now I will take pi common, h common. I will left with r square minus r square. This is my cubic units. Okay. Next is our curved surface area. Now students, next time onwards, curved surface area I am going to write it as CSA. Okay, C dot S dot A. Right? Now curved surface area of hollow cylinder. Will be equal to external surface area plus internal surface area, which is equals to 2 pi r h plus 2 pi r h. Right? Our curved surface area we have already learned in case of solid figures that it is 2 pi r h. So here also we will apply the same, only the radius will change in case of external and internal. So this is equals to 2 pi, I will take common, r plus small r will remain, and h also I will take common. H I should have taken it over here, but I have taken afterwards. So 2 pi r plus h square units. Okay, next is our total. See, this time I am writing T S dot A. It means total surface area, okay, of hollow cylinder, which is equals to, this part will be equal to our curved surface area of hollow cylinder plus area of the base rings plus area of the base rings. Now curved surface area will be 2 pi r h plus 2 pi small r h, right? This is what our curved surface area was. Now plus area of the base. So area of the base means our outer base was pi r square. This should be actually 2 pi r square minus pi r square. You know why 2 comes? 2 comes because the top part, right? The topmost part, if we are taking, see this one, if we have to find out the area of the topmost part, I should have write it as this area. Area should be written as pi capital R square minus pi small r square. Then only I will get the area of the material. Okay, because here area means area of the material only. So pi capital R square minus pi small r square. Right? Now the same thing is for the bottom part. So bottom part will also be area as equals to pi r square minus pi r square. Okay, so when we add, we'll get twice of pi capital R square minus twice of pi small r square. So that is what, that 2 I have written it outside. See, I have written this 2 here because of this reason. Now this will become equal to 2 pi h r plus r plus 2 pi r square minus r square. Now this is equals to 2 pi we can take common, then this is r plus r, and this is r square minus r square. So r square minus r square can be written as capital R plus small r and capital R minus small r. So capital R plus small r I can take common, and I will left with h plus r minus r. I hope all of you understood that how these formulas are derived, how I am deriving the formulas and how I am getting the formulas, and these formulas I am going to apply while I will do the questions. Clear? If you have any doubt regarding anything, you please ask. You can write in the comment box, right? You can write in the comment box so that I can see. If any problem, any doubt you have, please do ask, so that I will also understand that which part you are not understanding, where you have problems, so that it can be solved more. Yes. Yes. Okay. Now, till now, we have learned about cuboid, cube, cylinder, and in cylinder we have learned about hollow cylinder and solid cylinder, right? And I have given so many examples regarding this, which daily life we are using. Okay. Now we will move for cone. One more solid figure, that is cone. Cone. Cone also you have seen, right? Like ice cream cones, like conical tents. Okay. uh, Birthday caps, right? So many places, funnels, many places you might have seen cones. So right now we are going to derive the formula for cone. Hello, Mr. Alim. Hello, Mr. Alim. Mr. Alim, if you are not understanding anything, please do write in the comment box. But at least you use a good languages. You know, you use proper language. You ask the doubts, but don't write anything unnecessarily. Please, it's a request. Hello, Zen. Hello, Mr. Zen. Hello, Zen. Whatever today I am teaching, did you understood? Did you understood all the things? Hello Zen. Did you understood the topics which we had discussed? Okay, okay, fine, fine, very good. If you have any problem, please do write in the chat box, okay? I mean in the comment box, okay? Okay. Now let us continue with cone. As you can see, as you can see, cone is a figure. The base is circular in shape. Okay, the base is circular. So here in this case, this part is our radius. Okay, and this is the height of the cone, which we denote by h. This is the height which we denote by h, and this is the radius which we denote by r, and this part is the slant. This slanting part we denote by L. Okay, so this is my slant height. Okay, so this is my slant height. Now in this case, the first part comes volume of cone. The very first thing is what is slant height. So how I can find out slant height? So slant height L will be equal to, see, if you observe properly, this is a right angle triangle. Okay, so it is making a 90-degree over here, right? So when this is a right angle triangle, so this part will act as a hypotenuse. This is my base and this is my perpendicular. Okay, so H is the perpendicular, R is the base, and L is the slant height. Okay, so I can find out slant height L as under root of h square plus r square. Okay, so this is the formula to find out the slant height. Now comes volume of the cone. 1 by 3 pi r square h cubic units. Cubic units, right? 1 by 3 pi r square h. Next is curved surface area cone. So this is equals to pi r l, right? And L is what? L is our pi r under root of h square plus r square, square units. And the difference between height and slant height is, see, height is always height is the distance between the vertex to the bottom. I mean, see, height is this distance from the vertex, the straight distance, okay, the straight angle that is to this bottom. This is your height, right? But slant height is from the vertex till one of the side of the cone. Now is it clear, Mr. Zen? Now is it clear? Okay, clear? Height is what? Slant height is what? Slant height is the height which a vertex, that is the distance between the vertex and one side of the cone, and height is the distance from this the vertex till the top of the or you can say to the base, right? This is your height. Okay, Zen, Mr. Zen, now is it clear about height and slant height? I have already explained. I have already explained you. Okay, so now total surface area. Total surface area is this circular area to all the sides, that is curved surface area plus area of the base plus area of the base. So curved surface area is what? Curved surface area is pi r l. Okay, and the base is circular in shape, so it will be pi r square. Okay, so this is equals to, what we can take common? We can take common pi r common, and we left with l plus r. Okay, so pi r we have taken common, and that is our square units. Okay, so this is our cone. In case of cone, we will not go for solid cone or hollow cone. Cone is cone. In case, while I will show you the questions based on cone, in case if any question comes regarding hollow cone or solid cone, that time I will explain about what is hollow cone, right? But right now we will do most of the things based on solid cones only. Okay, yes, thank you Mr. Zain that you understood. Thank you so much. Now we'll proceed for sphere, our fifth solid 3D solid shapes. Okay, sphere. In case of sphere, you have your ball is a sphere, right? A solid sphere can be there, or hollow sphere can be there. Okay, so let us talk about sphere now. So sphere is a ball shaped, round shape. This is r. R is the radius, right? So in this case, volume of sphere that is equals to 4 by 3 pi r cube, cubic units. Okay, this is the volume of sphere. If we are talking about surface area, now we will not talk about curved surface area or total surface area, because here in case of sphere we are not having any sides, any vertices, anything, right? So we will not go for curved surface area, lateral surface area, nothing like this, only surface area. So surface area will be equal to 4 pi r square, square units. Okay, so this is my surface area. Now if I take half of this means in the shape of bowl. Okay, this is my bowl. Okay, so this is R. So this is hemisphere. So when I will take hemisphere, that time the volume will be half of the sphere. So volume will be equal to half of 4 by 3 pi r cube. So that is equals to 2 by 3 pi r cube. This is cubic units. Okay. Similarly, when I will come for this part, now the thing is, here I will get curved surface area and total surface area. Why? Because I cut the sphere in two parts, right? So that the topmost part becomes a circular. It becomes circular. Hello, Mr. Sam. Which board application are you using? Okay, I will give you answer about this. Okay, let me finish this part, then I will give you answer. Okay, so this topmost part is circular in shape. So here in this case, curved surface area will be equal to half of this part. Okay, curved surface area means this part, this surrounding part all over. So this is half of 4 pi r square, that is 2 pi r square units. Okay, then comes total surface area. Total surface area is, that is this curved surface area and the area of the topmost part. So curved surface area plus area of top part, or you can say area of the base. Anyways you can call it as. Okay, so I'm just going to write it as area of base. So now in this case, what is my curved surface area? Curved surface area is 2 pi r square, and area of my base is pi r square, because it is circular in shape. So this is equal to 3 pi r square units. Okay, so my total surface area will be 3 pi r square. Okay, so today we have learned about many topics as cuboid, cube, cone, cylinder, hemisphere. Okay, let us come to the gist once more. See, from the starting, whatever we have learned, just go through once. See, here we have learned about your cuboid. The figure I have shown, the formulas, how we are deriving, how we are writing, that I have shown you. Then comes to cube. Cube and cuboid are the same. See, cube and cuboid are the same. Right? So here the derivations I have shown you. Then comes your cylinder. Then comes cylinder. About cylinder I have shown you how we can find out the volume, curved surface area, total surface area for solid cylinders or for hollow cylinders, right? So this is the formulas for solid cylinders. Then we have discussed about hollow cylinder. Here hollow cylinder is like this, which I have explained you, that for hollow cylinder it is very important to find out the thickness of the material used. Okay, or thickness of the metal used. If it is metal used, then metal used. or if something else, then material used. Okay, anyways you can write. Now after this I have already discussed, see here I have shown you how we can derive the formulas, right? Derivation of the formulas are also there. Then this is the cone, which just right now I have explained you that how we can find out, the total surface area. Then comes sphere, then comes hemisphere, right? I think that my uh, video will be beneficial for you to understand about the formulas. Please to write in your record in your system, right, so that it will be beneficial for you in the future. Okay. Yes, Mr. Sam, about your answer, which board application I am using, that is, you just zoom it and you will find out a smooth draw is written on the top. So that board application I am using. Okay. So this is my application. This is for today's class, right? In case if you have any problem regarding this, please do write in the comment box. Today I am doing this one. Today I have shown you this mensuration formulas. Next class we will do questions based on these type of on these solid figures and also on combination of solids. Okay. Mr. Sam, now is everything clear? As I said, okay. So today I am going to close my class, right? So have a nice day, have a good day to all of you, those who are